Hello, chemistry class. This is Coach Jeans, and this is a video podcast on dimensional analysis. And what you're going to do if you are in my class, you'll want to get your composition notebook out and you want to turn over to pages 23. And you're going to start on the odd side. In the outline, I told you to just leave this blank for teacher notes. So here's where you're going to fill in those teacher notes. So start on the odd side on page 23, and you'll want to write down these 5 steps to dimensional analysis. So pause the video at this point and write down these steps. Okay, so we're back. Now, let me go back for just a moment and talk about what dimensional analysis is. I've got a parentheses T-chart. You'll see why I use this as a kind of a nickname, and I didn't come up with that. Another science teacher did. But so we call this a T-chart. But dimensional analysis is sometimes called factor label method, but it's a way of taking units and handling the units of measurements and being able to convert from one unit to another unit, being able to do several different things and handling different dimensions, different units, different measurements. Okay. Now, it's not just something that we use in chemistry. It's something you could use this method to do all types of stuff with numbers in all different kinds of fields. So I think it's really good. And I hope you pay attention to this and you follow along with me and you really get this down. Now, initially, when we start doing some of the early examples, there are other ways to do them. There are faster ways to do some of these simple initial examples. For example, you could just move the decimal place over when you're converting in the metric system. Maybe you can just do things more mentally. And that's fine for simpler things. But again, in these initial ones, I'm trying to show you a method. And so I would like for you to follow along with me, use this method, because as we progress on, this is going to be the best way to do it. And as we get on in through the year, we start dealing with figuring out how much product can be formed if you're given this much of the reactants, or how much reactants are needed to form this much of a product in a chemical equation. You're going to need to do it dimensional analysis way. And if you don't, you're going to be behind and it's going to cause you a lot of trouble. Okay, so let's enough with that. Let's move on. Number 1, we're going to write all numbers as fractions, okay? Number 2, we write everything with its units. No naked numbers. Numbers always have units with them, so put the unit along with the number. Then thirdly, we're going to arrange these in conversion factors so that the units will cancel. All right, you can see I'm still here at school. So arrange the conversion factors so that the units will cancel. So we handle units the way we do numbers. In fractions, you can cancel things on top with things that are on the bottom. Fourthly, numbers on top, we simply multiply. So if you have something on top, you hit the times symbol, hit that number. If the number's on the bottom, you hit the divided by and put that number in. Now remember, ones do not change the values. If you multiply something by a 1 or you divide something by a 1, you still have that same number, okay? All right, so let's switch over to our camera. All right, so here we're going to do a few problems. So just going to write these out on my pad and you follow along with me, and you'll want to jot these down in your notebook as well. All right, so first of all, example number 1. We're going to do a simple one, 37 kilograms to grams. Now, I know a bunch of you right now, you probably do this, you're done. But follow my method, go along with me. So the first thing you're going to do is you're going to draw what I call a T-chart, because it looks like a fat T. Really what it is this factor bars, okay? And then what you do is you put the number that you're given in the problem in the top box on the left, the first box. Now below it, you can leave it blank, or sometimes I'll put a 1, but a lot of times I'll just leave it blank. It's understood the 1's there. The next thing that you do automatically, whatever unit you have in this top left box, it automatically goes to the bottom right box automatically. That way it will cancel out, and that's what we're trying to do. Then we ask ourselves, do I know a relationship between kilograms and grams? Well, let me think about it. Well, kilo means 1,000, right? So that means that 1,000 grams equals to 1 kilogram. So now I'm going to arrange this like a conversion factor. Now, a conversion factor is simply where you take an equivalency and you make it a fraction. So we could have 1 kilogram over 1,000 grams, or we could say 1,000 grams over 1 kilogram. And those are equal because what's on top equals what's on bottom. All right, so the question is which one do I need to use? Well, we look at it. Kilograms had to go on the bottom so to cancel. So I would use this one. I would put the 1 beside kilogram, and on the top box on the right, I put 1,000 grams. Now, kilograms cancel out, like I said. We are in grams, so now we're going to put the equal sign, and we're simply going to say 37 times 1,000, and you can do that without a calculator, 37,000 grams, okay? And you might want to put a box around that just to indicate that's your final answer. And I know, again, a lot of you could have did that a lot quicker, but we're learning a method, so just learn the method, follow these examples. Let's go on to example number 2, okay? Example number 2, we're going to take 1.2 kilometers, and we're going to convert those over to millimeters. How many millimeters is that? Okay, now you could use your little moving the decimal method on this one as well, but again, let's do it using dimensional analysis, the T-chart. So we're going to draw our T-chart. We're going to put the number that's given to us, 1.2 kilometers. Okay. Again, you can leave this blank down here, which most time I'll do, but I'll go ahead and put the 1 in it. Okay, that's a decimal point. Kilometers automatically go down to the bottom, okay, right of the next box. Now we need to ask ourselves a question. Do I know how many millimeters are in a kilometer?
Cheyenne Davis, please report to the main office. Cheyenne Davis, please report to the main office. Thank you.
Okay, so, well, I don't know exactly, but I do know a relationship between kilometers and meters, right? So in this one, I can convert kilometers to meters first. And then I know a relationship between meters and millimeters, so then I can convert to millimeters, right? Well, as we know, 1 kilometer equals to 1,000 meters, all right? So in my conversion factor here, I'm going to put meters on top. And what's going to go with the meters? Well, the 1,000 has to go with the meters. So I put that on top. 1 goes with the kilometers. I don't want to reverse that or else I'll get the problem wrong. Kilometers cancel out. Now I need to then go to millimeters. So I extend my factor bar 1 more time. Meters come down here to the bottom. Millimeters go to the top. So do I know a relationship between meters and millimeters? Yes, I do. 1 meter equals to 1,000 millimeters. So the 1 goes on the bottom with the meters, and the 1,000 goes on the top with the millimeters. Meters cancel out. So now I have millimeters left in my top box. That's what I'm trying to go to. That lets me know I can put my equal sign, get out my calculator, multiply 1.2 times 1,000 times 1,000. Those are all on top, so everything's multiplied. 1.2 times 1,000 times 1,000 gives you what? I'm going to write it down here. 1,200,000 millimeters. You could also put that into scientific notation and call it 1.2 times 10 to the 6th millimeters, okay? So either one of those are correct. I would accept either answer unless I specifically said put it in scientific notation. Okay, so let's go on to another example. Example number 3. And this one we're going to take 0.0125 milliliters, and we're going to figure out how many liters are there. Okay, let me move my camera down a little bit so we'll be able to see this one. So again, we're going to set up our factor bar. All right. We're going to put our number we're beginning with in our top box. Notice here I wrote the number and drew the factor bar around it. I do that most of the time. Milliliters is going to go here. Now, do I know a relationship between milliliters and liters? Yeah, 1 liter equals to 1,000 milliliters. Milli means 1,000. So we can put liters up here. The 1 goes on the top, the 1,000 goes on the bottom. Milliliters cancel out. Now this is on the bottom, so that means I hit divided by. So I punch in my number, 0.0125, hit divided by 1,000, okay? And what I should come up with is 0.0000125 liters, or I could call it 1.25 times 10 to the what? -5 liters. So either answer is okay. All right. Now let's go on to example number 4. Now let's do something that you just can't move the decimal place. The first 3 examples you could have moved the decimal place. Let's do a different thing. Let's say that you've got 4 weeks. You want to figure out how many seconds are in a week. Okay, so this one, you're not going to be able to just move the decimal place, are you? You're going to have to do it using some other methods. Now, dimensional analysis is the way I want you to do it. So learn how to do it this way. Now, so we're going to start out the same way we always do. We're going to draw our factor box, okay? Our T-chart. Weeks are going to go down here because they need to cancel. Now I need to ask myself a question. I don't know how many seconds are in a week. I might be able to figure it out, but that's the whole point of the problem, right? But I do know how many days are in a week. So I can go from weeks to days. So let's put days at the top. And there are 7 days in 1 week. So weeks cancel. All right, go ahead and extend my factor box. Put days down here. Now, do I know how many seconds in a day? Well, not exactly, but I do know how many hours in a day. So I can convert to hours. So put hours on top. How many hours in a day? Well, 24 hours, 1 day. We all know that. Days will cancel out. Now, how many seconds are in an hour? Well, again, I don't know exactly, not right off the top of my head. So I can put hours down here. And this time I can go from hours to minutes. So put minutes on top. Well, how many minutes in an hour? That's right, 60 minutes in 1 hour. Hours cancel out. Now I extend my box one more time. Minutes go to the bottom. Seconds go to the top. And how many seconds are in 1 minute? 60 seconds in 1 minute. So finally we get there, right? Minutes cancel. We have seconds on the top. We're trying to go to seconds. So now we can put our equal sign. So in our calculator, we're going to go 4 times 7 because it's on top, times 24, times 60, times 60. And when I do that, I should get something like this. 2,419,200 seconds. Now the problem is we have to look at significant figures. Now conversion factors like 7 days equals 1 week, 24 hours in 1 day, 60 minutes an hour, those are considered infinitely significant. So we don't worry about those. What we do worry about is the number we started with. And this number 4 has how many significant figures? 1 significant figure. So we need to round this off to 1 significant figure. So this is the first figure. This is what we're going to use to round. It's a 4, so that keeps that as a 2. And then we fill in the rest of it with zeros. So it rounds to 2 million seconds. Again, we could put that in scientific notation, call it 2. Actually, not correct. We would just want to put 2, and we would want to put times 10 to the 5th seconds. If we put 2.0, that would be 2 significant figures, and that would not be correct. Okay, so let's do one more example in this video. Example number 5. This time, let's go with something a little different. 3.9 times 10 to the 4th centimeters, and we're going to convert that to furlongs. Said what? I said furlongs. You ever heard of furlongs before, haven't you? Probably not. Furlongs is an old way of measuring distance. And as it turns out, 8 miles, that's 8, equals to 1 furlong. Okay, so we're going to use that. Now, we're in centimeters. So if we're in centimeters, that means that we're going to have to first convert over to something in miles. So we got to go to the English system. All right, so we're going to start it all. Just put down what we know. We know 3.9 times 10 to the 4th centimeters. We're going to draw our factor box. We're going to put centimeters down here to the bottom. Now, I need to ask myself a question. Do I know a relationship between centimeters and anything in an English unit? Well, I do. 1 inch is equal to exactly 2.54 centimeters, and that's an exact. So that's a good conversion to know and memorize and just have handy when you need it. So we can put inches on the top. 1 inch is 2.54 centimeters. Centimeters cancel out. Now we're in the English system, so finally we get to at least move forward. So now inches go to the bottom. Now, I don't know how many inches are in a mile. I need to get to miles so I can use this one. But I do know how many inches are in a feet. So 1 foot is 12 inches. Make sure the 12 is on the bottom where it belongs. Inches cancel. Now, do I know how many feet are in a mile? Well, yes, I do. Okay, so I put feet at the bottom, miles on the top. Why does feet go to the bottom? So it'll cancel. And if you know this, there is 5,280 feet in 1 mile. That's a conversion factor. All right, so I'm going to have to bend this down a little bit because I ran out of room there. Okay, so now we're going to go miles here, and here we're going to have furlongs, okay? Sorry about having to bend this down. But we know that there are 1 furlong is equal to 8 miles. Okay, so miles cancel like this right here. Now we're left over with furlongs. That's what we're trying to get it to. So now we can put our equal sign. So in our calculator, we're going to punch it in like this. 3.9. We're going to hit that second key. We're going to hit EE to the 4th power. Excuse me. We're going to hit divided by 2.54 because it's on the bottom. Divided by 12. Divided by 5,280. Divided by 8. Okay, so a lot of divide. Remember, if it's on the bottom, you put the divided by and then you put the number in. And be sure to use that second function on your calculator. So punch those numbers in. 3.9. Let me clear this out. 3.9, second function, EE, to the 4th power, divided by 2.54, divided by 12, divided by 5,280, divided by 8 equals, and you should get something like this. 1.93867. All right, so we need to round that off to the correct number of significant figures. How many significant figures are in this number here? Okay, 3.9 times 10 to the 4th. Well, that's the only part that counts, 3.9. So we're going to round this off to 2 significant figures. So we look at the 3. We don't worry about anything past it. That gets ignored. And so my answer should be what? 1.9. And the unit we need to put that with our answer is furlongs. Okay. Well, that's a little introduction to dimensional analysis. Come to class ready with any questions. We'll work some more examples, and I will see you in chemistry class.